What's up everyone, I'm Teacher T, and in this video we're going to equate the two definitions of E. This letter here, E, it's a constant, it's a number. The first definition is this limit definition, the limit as n goes to infinity of 1 plus 1 over n to the power of n. This converges to the number E. It's discovered in 1683 by John Bernoulli. Pretty cool. It's also equal to another famous definition, this series definition of E, which is 1 over k factorial as k is greater than or equal to 0. Now, the letter E, if you expand it out, it's an irrational number. It equals 2.718281828, on and on and on. And we just plug in a few numbers to show just that these two definitions converge to the same number. If we look at the first one, we plug in some values for n. Let's say n is 1,000. Then this is our value for E, 2.7169239. So pretty close. If n is 100,000, we're even closer, 2.7182682. And if n is 1,000,000, then the number is 2.71828. So we're getting closer. We're 05, we're getting closer. Now let's look at this series definition. So if we want to add up k terms, so if we add up 10 terms for k, we get 2.71828. So a little close, but not quite there yet. If k is 100, we're even closer, 2.718281828. And it converges a lot quicker than when the limit definition, but they both converge to the same number. Now I'm going to show you that these two definitions are equivalent by converting one into the other. So to show that these two definitions are equal to each other, we'll start with the limit and we'll expand this out. So let's look at it. It's 1 plus 1 over n to the power of n. And that really means we're going to multiply itself by itself n times. So we have 1 plus 1 over n times 1 plus 1 over n times 1 plus 1 over n, and on and on and on. And if we expand this out, we're going to have 1, this is like FOIL here, 1 multiplied by itself through all these factors, 1 times 1 times 1, do that n times, so that's 1 to the power of n, plus, now for the second term, we're going to multiply 1 by itself, except rather than doing it n times, we're going to do it n minus 1. So we're going to multiply 1 by itself, all except for the last factor. So it'll be 1 to the power of n minus 1, and then that last factor will be 1 over n. Now, there's a number of combinations that we can multiply all the ones except for the second last factor, or maybe the third last factor, or maybe we'll multiply 1 over n with the first factor. So there's some number of combinations of 1 to the power of n minus 1 times 1 over n. And that combination is a coefficient, which we're going to put right here. It's nc1, which is n choose 1. And now we're going to look at the next term. So the next term, we're going to multiply all the ones together except for 2 terms. So that'd be 1 to the power of n minus 2. And then those last, or 2 factors, then those last 2 factors will be 1 over n, and we'll multiply 2 of them, so it'll be 1 over n squared. And now again, there's some combination that we can come up with multiplying any of the ones except for 2 of the factors. So we'll have another combination there called nc3, another coefficient. Again, we can look at the third one here, so n choose 3. 1 to the power of n minus 3 times 1 over n cubed plus, and then on and on and on. This goes for, eventually it's going to go to infinity. Now this coefficient, it's called the binomial coefficient, and generally it looks like this. So if it's nck, it's like n choose k, that equals n factorial all over n minus k factorial times k factorial. That's what the coefficient is. And k is the term. So if we're looking at the first term, k is 1, so nc1, nc2 would be, k would be 2. Now if we would expand this out a little bit further, we get 1, because 1 to any power is still 1. Plus, now nc1 is n factorial over n minus 1 factorial times 1 factorial. And all of that is multiplied by 1 over n. We can ignore the 1 to the power of n minus 1 because 1 to any power is just 1. So that's 1 over n. Plus, now the third term here, so that's n factorial over n minus 2 factorial times 2 factorial. That's that second binomial coefficient times 1 over n squared. Plus the next binomial coefficient, which is n factorial over n minus 3 factorial times 3 factorial. And then, of course, that's multiplied by 1 over n cubed. And there we go, plus and on and on and on. Now, let's move this up a little bit, and we're going to simplify this a little bit. So equals, now 1 is still 1, plus, now if we're to expand this out, the factorial means we multiply the number by one number less. So n factorial would be n times n minus 1 times n minus 2 times yada, 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 all the way to 1, divided by, now n minus 1 factorial is n minus 1 times n minus 2 times blah, 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 all the way to 1. Now I'm going to move things around a little bit. I'm going to put this 1 over n here, and then the 1 over 1 factorial will just move to the end. We're multiplying things together, so we can just move these factors around. Plus, now let's expand this second binomial coefficient. So n factorial is n times n minus 1 times n minus 2 times n minus 3, yada, 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 all the way to 1. And then this second part is, oh, I got to include this here, all the way to 1. N minus 2 factorial, which is times n minus 3, all the way to 1. Again, we'll move the things around a little bit. We'll put the 1 over n squared here, and then the 1 over 2 factorial, we'll just move it to the end. Now for this third term, it's n factorial again is n times n minus 1 times n minus 2 times n minus 3 times n minus 4. I think I'll just yada yada all the way to 1, all over n minus 3 factorial, which is n minus 3 times n minus 4, yada, 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 all the way to 1. And we'll put brackets around here. All this is times n cubed, if we just move the n cubed inside the bracket, and all over 1 over 3 factorial. Now look how much we can cancel. These n's cancel, the n minus 1 cancels, the n minus 2 cancels, all the way cancels. So what we're left with is 1 plus, everything else cancels except for the 1 over 1 factorial. Now let's look at the third term here. See this? And one of these n's cancel with one of these n's down below. The n minus 2, n minus 3, all of these down here cancel. And what we're left with is n minus 1 over n times 1 over 2 factorial. That's nice and simpler. Now the fourth term here, again, we have the same canceling. This n cubed cancels to n squared with this other n. All of these other n's cancel, n minus 3, n minus 4, yada, yada. And what we're left with is n minus 1 times n minus 2 all over n squared. Yeah, we've got to add this plus on and on and on. Times 1 over 3 factorial, because that's still there. Good. Look at that. Now, we need to apply the limit. But before that, what we're going to do is, so we'll leave these terms here, 1 plus 1 over 1 factorial. I'll just rewrite it here. So n minus 1 over n. Just going to rewrite it nice, a little bit cleaner. We're going to multiply the numerator by 1 over n and the denominator by 1 over n. Good. And if we do that, what do we get? Okay, so this 1 and the 1 over 1 factorial, that's still there. Well, we have the 1 over n canceling with one of these n's here, so we're left with 1 minus, now 1 times 1 over n is just 1 over n, and all of that's divided by 1, because 1 over n times n is just 1. And that's times 1 over 2 factorial. Great, now let's look at our last term here that we're dealing with. Now, let's factor this out. So n minus 1 times n minus 2, if we FOIL it out, as we say, it's n squared minus 3n plus 2 all over n squared, 1 over 3 factorial, plus on and on and on. Now, if we multiply, same thing, top and bottom by the denominator by 1 over n squared. There we go, 1 over n squared. What we're left with, now we multiply that 1 over n squared throughout the bracket, so we're left with 1 minus 3 over n plus 2 over n squared. And all of that is over 1, because 1 over n squared times n squared is 1. I'll close the bracket here. And then the 1 over 3 factorials along for the ride, and plus on and on and on. All right, now let's apply the limit. So we're going to apply the limit, remember, because it's part of the definition, as n goes to infinity, of all of this, 1 plus 1 over 1 factorial plus 1 minus 1 over n. Now we can lose the 1 in the denominator because every number we could write as over 1. So this is just 1 minus 1 over n times 2 factorial plus, bracket here, 1 minus 3 over n plus 2 over n squared, close bracket, times 1 over 3 factorial, plus on and on and on. Now we can apply the limit here. And if you see, if we apply the limit, this 1 over n goes to 0. Because as the denominator becomes infinitely large, this fraction becomes smaller. A huge number under 1 over a large number is essentially 0. The limit is 0. And we can do that the same with 3 over n and 2 over n squared, that sort of thing. So what this comes down to is 1 plus 1 over 1 factorial plus, now this is just 1 here, so it's 1 times 1 over 2 factorial plus, again, all these terms here cancel except for the 1, so it'd be 1 plus 3 factorial, 1 over 3 factorial plus on and on and on. If we write this a little bit simpler without the 1s, it's 1 over 1 factorial plus 1 over 2 factorial, plus 1 over 3 factorial. And you can see the pattern here. It's very clear. Let's just write this in a summation. So it's the sum as k is greater than or equal to 0 of 1 over k factorial. That's what we're seeing here, which is essentially our Taylor series definition of E. So there it is. Hope you enjoyed it. I'm Teacher T. Thanks for watching. See you in the next video. Cheers.